sample spaces. So situation where you have different possible outcomes. It's called an experiment. So that's what an experiment is. So only one of these outcomes is going to happen. Only one of these outcomes can actually occur. And then think of it like this. So for example, tossing a coin, rolling a die, and these are experiments. So these are experiments. So now let me tell you what the sample spaces are. Sample spaces. So the set of all possible outcomes of an experiment is called the sample space. Sample space of that experiment. Okay, so for example, if you are tossing a coin, so the experiment is to toss a coin. Okay. So how many different outcomes are there to this experiment? To toss a coin, so how many outcomes are there? Two. So the outcomes are you get heads or tails. This sample space would be, so for example, if you toss a coin, the sample space is the set. So heads. So there are two outcomes, heads and tails. And the sample space is just a set of all these possible outcomes. If you roll a die, then the sample space is a set. All the numbers 1, 2, 3, 4, 5, and 6. When you roll a die, there's 6 outcomes. You can get the number 1, 2, 3, 4, 5, or 6. So the sample space is just that set. So, in general, when you do an experiment, it might be ambiguous, like what the sample space should be. But in the problems you'll see, it's usually obvious, or they will explicitly tell you what the sample space should be. But you can have an experiment, and there might be two ways. Like, so given an experiment, one person might think that the sample space is one set, and another person would think the sample space is another set. But it should be clear what the sample space should be taken to be. So, we use this notation generally. So we use this capital omega for outcomes. So Greek O. Right, so we use this capital omega to stand for the sample space instead of all the outcomes. And then the elements, so the elements of this set capital omega are usually denoted by lowercase omegas. So this capital omega is like, it stands for the sample space, which is the set of all the outcomes. Same thing with events are. So an event is any subset of the sample space. So we say that an event occurs if the outcome, so if the outcome of the experiment is an element of that event. Okay, so you're going to have this sample space. It's a set of all the outcomes. And then you can just choose a couple of these possible outcomes and form a set of those outcomes. And that would be called an event. Okay. So, for example, if the experiment is rolling a die, so let's say that the event E is that the number shown is even. So we're going to roll a die, and then we have this event E, and it's the event that the number shown on the die is even. Okay. So this event E, it would actually be the set of 2, 4, and 6. That's a subset of this sample space. You would say that this event E occurs if the outcome of the experiment is 2, 4, 6. Okay. So events are just subsets of the sample space. Okay. If you want the event that the number is odd, then that event would be the set 1, 3, and 5. You should always think of events as subsets of the sample space. So it looks like this in general. So you'll have an outcome, little omega. This outcome will be in some set of an event. Okay. And this event will be a subset of this sample space. So i.e., it looks like this. So you'll have an outcome that will be in some event, and this event will be a subset of the sample space. So let me tell you this now. So if E and F are events, then if you take the union of E and F, that's an event. If you take the intersection, that's also an event. If you take omega without one of these, then these are all events. These are also events. So we say that two events, let's say E and F, are mutually exclusive if the disjoint, so if they are disjoint, so i.e. If the intersections can be, so you have E intersect F, and then you can be intersect. So you'll have an experiment that you do that has different outcomes, and then you'll have a sample space for this experiment. The sample space is just a set of all the possible outcomes. And so you can form events. Events will just be subsets of the sample space. I'm going to tell you about compound experiments. So you consider an experiment that has finite many steps. So you're going to do this experiment. It's going to have finitely many steps. Okay. So each step is a sub-experiment. Okay. So think of this example. So here's, let me see for example. So we can have two examples here. So this will be, these are very, we'll have two compound experiments. So I'll call the first one compound experiment A. Compound experiment A. So what you do in this experiment